Hey there everybody, thanks for joining me today. Today is your test review, so we're going to be doing just a little bit of everything. Let's get started. So in the first section here, all 6 of these, you're going to be writing function or not a function. So you know if any of the x values are repeated, then it is not a function. For it to be a function, the x values have to not be repeated. So let's take a look at number 3 here. Are any of these x values repeated? We have 5, 11, 17, and 6. No repetition there, so that means it is a function. So I'm going to write fun. Okay, what about over here on number 4? Are any of these x values repeated? Look at that. We've got 5 there, and we have 5 there. So that means it is not a function. No fun. Now you might be asking yourself, what if the y values get repeated? It doesn't matter. You can just totally ignore the y values in this case. Let's go on to number 5. All right, so same thing here, it's just written differently. If any of these x values are connected to 2 different y values, then it's not a function. Okay, so let's check the -3. It only has one line coming out of it. It's connected to one y value. Okay, so that's good. -4, only connected to 1. -5 is only connected to 1. 0 is connected to 1. 3 is connected to 1. And 4 is connected to only 1. Now again, you might be saying, well, what about this 5 over here? It's connected to 2. But it doesn't matter because it's over here on the y side. You only need to check the ones over here on the left. In this case, they each are connected to 1 and only 1, so it is a function. Fun! All right, there we go. Let's take a look now at number 8. So in this section, we're trying to say whether it's function or not a function. And we're trying to say whether it's linear or nonlinear. Okay, so function or not a function, that's where we're going to use our vertical line test. So you can draw lines straight down through the graph, or you can set your pencil down, whichever way you want to do it. I'm just setting my pen down right now. Now, no matter where I put my pen on this graph, how many times is it crossing the graph? And when I say the graph, I mean this part of it right here, okay? I'm not talking about the grid or the axes. I'm just talking about that part. How many times am I crossing the graph? No matter where I put it, I only cross it once. So it is a function. Now, what about linear or nonlinear? Guys, I know these look like straight lines, but it takes a turn in the middle and goes the other way, so it is nonlinear. For it to be a line, it needs to be all just one direction. Nonlinear. Okay, let's look over here at number 10. So function or not a function? Well, let's do our vertical line test. Set it down this way. Does it cross more than once? Oh my goodness, it crosses 1, 2, 3, 4, like 5 times. It is not a function. So we're going to write no function. And then as far as linear or nonlinear goes, well, is this a straight line? It's a curve. Definitely a curve, so definitely non-linear because it is not a line. All right, let's look at the next page. So here we have numbers 7 through 14. Oh, this is just continuing like the other section. So function or not a function, or linear or nonlinear. So first of all, function or not a function. Now we have this graph right here. See, it's a vertical line, just goes straight like this. So if I do another vertical line on top of it, I'm going to set my pen right down on top of it. Can you see that my pen crosses that line in an infinite number of places? It's point after point after point. In fact, it's all of the points. So that is definitely more than once, which means it is not a function. Now, as far as linear or nonlinear goes, is it a straight line? Yeah, sure is. Linear. Okay, moving right along. So now we have to look at these equations and figure out if it's linear or nonlinear. So the name of the game here is exponents. And when I say exponents, that's the little number up at the corner. Like if I had x to the second, that 2 is the exponent, right? So basically, if there is an exponent, it is not linear. So exponent equals nonlinear. And if you were to play around with Desmos and plug some equations in that have exponents, you'll see that the lines start going all kinds of curvy ways. It's pretty fun. So let's just look at 17 and 18. In number 17, x equals 2. I don't see any exponents, do you? No exponents, that means it is linear. All right, what about 18? You see any exponents? 5 to the x. Yeah, this little guy right here, it's an x, but it's actually the exponent, so that means it's going to be nonlinear. Okay. All right, let's go to our final section. This is the fun one, right? Where we get to figure out the rules and the equations. Okay, so now on your previous assignments, we've only been figuring out the blanks in the output section. Today we have a blank in the input section, so let's talk about that a little bit. Before we can figure out that blank though, we have to figure out the rule. So it looks like 24 is becoming 6, 32 is becoming -8, and 36 is becoming 9. First thing to ask yourself here, is it getting bigger or is it getting smaller? It's getting smaller, right? So what operations make numbers smaller? Multiplication, division, addition, and subtraction are your choices there. Division and subtraction make numbers smaller, right? So it's gonna be one of those. Let's figure out which one. Let's try subtraction first. So what's the difference between 24 and 6? Well, let's do 24 minus 6 to find out. And my calculator is telling me that's a difference of 18. So that's 18 right there. I'll just jot that down. And now what's the difference? I'm gonna just go with my positive numbers. I mean, why not make it easy, right? 36 minus 9. Oh, that's a difference of 27. So right off the bat, I know it's not subtraction because this set and this set, they have different differences. Okay, so it is not subtraction. Let's go with division. 24 divided by what equals 6? Now I'm thinking 4, right? But if you're not thinking that right off the bat, you can always do 24 divided by 6. And that will tell you the answer there. Sometimes if there's like really big numbers, that is a really helpful trick to know. So 24 divided by 4 equals 6. Now we just need to see if that holds true with the other lines. -32 divided by 4, that's going to equal -8. That's good. Okay, 36 divided by 4. Let's see, 9 times 4 is 36. So that holds true too. So to fill in this blank, we need to figure out what divided by 4 equals 4. Now you might know off the top of your head, but if you don't, what can you do? You can use your inverse operation. What's the opposite of divide by 4? Multiply by 4. So we could do 4 times 4 to find this blank. 4 times 4 is 16. And then it's always nice to just double check, make sure you're on the right track. So think in your head, 16 divided by 4, oh yeah, that equals 4, so we got it right. All right, so that rule is divide by 4. And so our equation, remember those equations, they always start with y equals. And the inside, that's the x, and the outside is the y. So what are we doing to the x's to make them turn into y? Well, we're dividing them by 4. So you're going to do x divided by 4. You can write it like this. It's the way we usually write it. If you wrote it like this, I would not mark it wrong. But this is just kind of more standard here. All right, so every x divided by 4 equals the y, and that's what we have right here. It's just kind of flipped around in the other order. All right, so that was 20. As you can see, we're also going to take number 21 right here. So our inputs, we have 2 turning into 5, 7 turns into 20, and 6 turns into 17. So are the numbers getting bigger or smaller? They're getting bigger. So what operations are we going to think of? Probably multiplication and addition will be the ones we're going to start with. So 2 times what equals 5? Well, that's not a nice round number, but let's find it out anyway. So 5, the easy way to find that out is to do this number divided by that number. 5 divided by 2 is going to be 2.5. Now this one, I don't know off the top of my head. Let's do 20 divided by 7. 2.8. Okay, now, are those the same? No, they're different. So guess what? It's not just multiplication. What about addition? 2 plus what equals 5? 2 plus 3 equals 5. All right, so let's add 3 to this one. 7 plus 3 equals, oh man, 7 plus 3 definitely does not equal 20. Excuse me. So where does that leave us? It leaves us with the idea that this is probably going to be a 2-step rule, which means you might multiply by something and then add something or something like that. So 2 steps in it. So this is where you're going to want to maybe play around with different numbers. I would definitely suggest timesing everything by 2, and then timesing everything by 3, timesing everything by 4. Let me walk you through it. So let's multiply everything by 2. 2 times 2 equals 4. Now how do you get from 4 to 5? You add 1, right? Okay, so that's times 4 plus 1. I totally did that wrong. 2 times 2 is 4. Oh, I see what I did. Okay, 2 times 2 is 4. I'm just going to scribble that out. 2 times 2 is 4, plus 1 is 5. Okay, so we're doing times 2 plus 1. 7 times 2 is 14 plus 1 equals 15, not 20. So times 2 plus 1, that is not the rule. Let's just ax you out. Let's try times 3. Okay, 2 times 3 plus, okay, 2 times 3 equals 6. Now, to make it into a 5, you're not going to add anything. You're actually going to have to subtract. So we're going to try times 3 minus 1, okay? Hopefully you can read that. Let me write it again here. Times 3 minus 1. There we go. So this is what we're trying right now. So 2 times 3 is 6, minus 1 is 5. Now I'll do it with the 7. 7 times 3 is 21, minus 1 is 20. Ooh, hey, it's worked for 2 of them. That's nice. 6 times 3 is 18, minus 1 is 17. Okay, it looks like we have a winner right here. So if that hadn't worked, I would have crossed it out and gone on to the times 4 option, but I don't have to because I found one that worked. So let's just go with it. So our rule is times 3 minus 1. Okay, now let's fill in this blank. 8 times 3 is 24. 24 minus 1 is 23. And for the equation, okay, so I've got my x's here and my y's there. So you always start with your y equals. Now what are we doing to those x's to make it turn into the y's? It's basically going to be the same as the rule, pretty much, right? First you multiply it by 3. So how do you write x times 3? We don't really write it that way, the way I just said it. What we usually write is 3x, right? So start with that, and then you have to subtract 1 from it, and it's just going to look like that. So that's how you do that. And you guys are all set. If you have any questions, let me know. Let your teacher know. We love hearing from you. And good luck on the test. You're going to do great.